Okay, I want to talk for just a minute about the sun's rays and how that drives climate. So I want to start by looking at solar intensity and latitude. So you'll see here pictures showing part of the globe, and we're going to focus on two parts, the equator and the pole. So coming in from the sun, we have rays here represented as red lines. I want you to notice whether you're at the equator or the pole or anywhere in between, those lines are basically evenly spaced. You have the same amount of energy coming from the sun. However, I want you to notice how they hit. At the equator, these rays hit more head-on, so the rays are focused in a much smaller area. Whereas near the pole, you have a much more oblique angle, so even though you have the same number of rays, they're spread over a much larger area. This means the areas near the equator get much more solar intensity than areas at the pole, so they get much more energy than areas at the pole. So obviously, that makes the equator warm and the poles cool. However, it's a bit more complicated than that. Once the equator gets warm, when there's differences in temperature, heat will be transferred to try to correct that. And we're going to look at heat transfer here by convection. So the warmer area at the equator begins a convection current. To represent that, I'm going to draw some pictures here around this view of the Earth. So here again we have the sun's rays coming in. They're more intense at the equator, so the air warms up at the equator. To show that, I'm going to show air rising away from the equator. Hot air, the air near the Earth's surface, is warmed by the Earth below, which is warmed by the intense rays from the sun. That hot air rises. As that hot air rises, it expands, it spreads out, and it cools. And as it cools, it sinks back toward the Earth, and it completes a convection current. The same thing happens in the northern and the southern hemisphere. So you'll notice here they're actually rotating opposite ways, but both convection currents between about 30 degrees latitude and the equator blow from 30 degrees toward the equator. So the winds in the tropical regions tend to blow toward the equator. Now, as this wind comes back down and descends about 30 degrees, while a lot of it does go back toward the equator, some of it turns toward the pole. As it moves back over the Earth is warm because of the sun, the air warms back up, that hot air begins to rise. It begins to rise at about 60 degrees from the equator. This is true whether we're north of the equator or south of the equator. So as this comes back down, it turns south, warms back up, and it begins to rise at about 60 degrees from the equator. That completes a second convection cycle in each hemisphere. So notice here, this convection cycle, the wind is blowing from the north toward the equator or from the south toward the equator. So in these tropical regions, the wind blows toward the equator. In these temperate regions where we live, the wind tends to go toward the pole. Now there's a third region that gets set up. As this hot air rises, it cools. It sinks to the Earth by the pole, completes the cycle. So once you get above 60 degrees toward the pole, the wind blows away from the pole. And I could draw the same thing on this side. Now, it turns out this is hugely important. It may not seem that way, but lots of things can be explained here. Now, I want you to think for just a second just about one thing, and that is what happens to the air near the equator when it's warmed by the sun. Well, first it gets hot, but lots of water near the equator, so hot water, a lot of it evaporates, so there's a lot of moisture in the air. So that hot air has lots of moisture. As it rises, it cools. When that moisture cools, it forms clouds. And those clouds cause lots of rain. So this is an easy way to understand why tropical regions are warm and wet. They're warm because they're warmed by the sun, but as that hot air rises, it cools. As it cools, it causes lots of rain, so you get lots of rain in the tropics. Now, as it rains, the moisture leaves the air. So this air has been rising, it cools, but it's losing its moisture. So as it starts to go away from the poles, it's now very dry air. As that dry air comes back toward the ground, it gets compressed. So when hot air rises and expands, it cools, but when cool air goes back down and gets compressed, it warms. So this air is dry and it's warm. So when it comes back down, we have warm, dry air about 30 degrees from the equator. If you'll notice, even in this very brief picture of a map, you'll see that a very common feature about 30 degrees from the equator, and those are deserts. So here we have the Arabian Desert. If you move back around in Africa, you have the Sahara. It's a little bit further north, but over here you have the Gobi, all about 30 degrees from the equator. The same thing actually holds true about 30 degrees south of the equator. We have desert in Australia, you have the Atacama Desert in South America, and the Kalahari here in South Africa. So if you understand how the sun drives these convection currents and how these convection currents cause temperature changes, you can start to understand climate. Once we understand climate, we're going to be able to understand biomes. Once we understand biomes, we're going to understand why there are different forms of life in different parts of the globe. The basics here, though, is circulation, heat transfer, energy. How does that affect our world?